All right. Hello, Tri-City Geometry class. This is going to be your only assignment for this week, this Holy Week. We have Good Friday off, so we're not going to worry about the quiz until next week. I probably will have you do that on Monday or Tuesday, though. Okay. And it's only going to be a quiz on 8.5. So let me pray. Father in heaven, please continue to bless us in our schooling. Help us this week, especially as we reflect on the work of Christ and his death and resurrection and all that it has accomplished for us and the world to truly trust you and praise you and live for you. And we pray in the name of our Savior, Jesus. Amen. So far we've looked at central angles, and they're going to have the arcs are going to be the same measure. We've looked at inscribed angles in the previous section, and their arcs are going to be half the measure. Now we're going to look at the question, well, what if you have some intersecting lines and you don't have that point of intersection either on the center, so that it makes a nice congruent figure with the arc, or it's not on the circle, so that it makes a nice inscribed half the measure. And so what happens if you move that point of intersection to different places in the circle or outside the circle? And basically, here's the general rule of thumb. We're going to walk through this, but if it's inside the circle, it's going to be the average of the two intercepted arcs. If it's outside the circle, it's going to be one half the difference. So if it's inside the circle, it's the average of the two intercepted arcs. If it's outside the circle, it's one half the difference. Because of course, as you keep moving away from the circle, your angle is going to get smaller and smaller and smaller and smaller. All right. So let's work our way through this. First, we have a lesson opener just to kind of review 8.3 and 8.4 with central angles and inscribed angles, right? We've got some central angles here. We've got some inscribed angles. So if the measure of arc AB is 44 degrees and the measure of arc DE is 94 degrees, first they want to know what's the measure of angle ACB. Well, what kind of angle is that? That's right, it's a central angle, so it has to be congruent with arc AB. So therefore, its measure is 44 degrees. How about number two, the measure of angle E? Well, what kind of angle is that? That's right, it's an inscribed angle, so it has to be one half the value of arc AB, so it's 22 degrees. How about angle D? Well, that's also an inscribed angle, and it also happens to be intersecting angle arc AB, so it has to be the same as number two, 22 degrees. Now, how about the measure of angle DBE? So what kind of angle is angle DBE? That's right, it is a inscribed angle, and so it has to be half the value of arc DE, so therefore it would be 47 degrees, half of 94, okay? So that's our central angles, number one. Those are our inscribed angles, 2 through 4. Now we're going to look at what about angles that are neither in the center and not on the edge, so that they're neither central or inscribed. How do we determine the value of those angles? So first of all, here we are on page 376, and we see some inscribed angles here, and we're reminded that they're half the value of the arc. So what happens if you continue to push that right ray down so that it actually turns from a secant, right, intersecting the circle at 2 points, into a tangent? Well, it's still going to be a kind of inscribed angle, right? You can see that these are all inscribed angles, so it's just going to be half the value of the arc created by the secant AB and the tangent BC. So here is our first theorem. The measure of an angle formed by a tangent and a secant that intersect at the point of tangency is one half the measure of the intercepted arc. So again, all this is saying is that this is another kind of inscribed angle, but it's an inscribed angle instead of with two secants, with a secant and a tangent. Okay, this is the middle of page 376. So here's our first example. Find the measure of WYX if line XZ is a tangent to circle Q at point Y. So we know that you've got a major arc, YW, that is 240 degrees. So what's the measure of arc WY as opposed to YW? Well, to find a minor arc, we subtract the major arc from 360. That gives us 120. So that should easily allow us to find the measure of WYX. It has to be half the value. Again, it's a kind of inscribed angle, so it's half the value of the arc. So what about the WYZ? Well, it's you could either do it two ways. You could say it's half the value of the arc, or you could say it's a linear pair, right, with angle WYX, so it's got to be supplementary to it. So it has to be 120 degrees. So there's a couple different ways you could find WYZ angle. Now we're getting into the issue of what about two secants that intersect inside the circle? How are you going to find the measure of angle 1? And if you look at your book, what they're saying is that the way you want to think about this is you want to think about a line, another secant drawn from B to C, right? Our line postulate allows us to draw a line between any 2 points. And what that makes us realize is that angle 1 is exterior to triangle BEC, and therefore, if we remember our exterior angle theorem, the measure of angle 1 has to equal what? It has to equal the sum of angle ECB and the angle EBC, right? We've created a triangle here, triangle EBC, and angle 1 has to equal EBC plus ECB. Well, what do you notice about angle ECB? Not only is it part of that triangle, but it also happens to be a inscribed angle. So therefore it has to be half arc AB. Angle ACB has to be 1/2 arc AB, which is 50 degrees. So ACB or ECB has to be 25 degrees. And angle DBC is another inscribed angle, so it has to be half the value of arc DC. So when I cut those in half, I add them together and I get the value of angle 1, angle AEB. So 25 plus 22. And so that we're going to get a formula from that, which tells us that angle 1 is going to be the average of arc AB and arc DC, or 1/2 the sum, right? The average of arc AB and arc DC, or 1/2 the sum. So we add these two together, we get 94, we get half of that, and that gives us angle 1. And also notice that angle DEC is vertical, so it's going to be congruent to that. And that's going to pop up a lot. You're going to be dealing a lot with vertical angles in this section, so just make sure you're paying attention to that. And you'll also be dealing with linear pairs, right? What's a linear pair to angle 1? Well, you could see that angle AED is a linear pair. Angle BEC is a linear pair, so they're obviously going to be supplementary. So this leads us to our theorem at the top of page 377. The measure of an angle formed by two secants that intersect in the interior of a circle on the inside is 1/2 the sum of the measures of the intercepted arcs. So again, to find angle 1, I would add the measure of angle AB and the measure of angle DC of arc AB and arc DC, and then I would cut them in half, or in other words, I would average them. So they want us to find the measure of angle 1, the measure of angle 1. So again, if you remember your theorem, what do you have to do to find this? I have to find the average between arc KJ and arc LM, okay? And of course, what I'm missing here is I don't know arc LM. So how do I find the measure of arc LM? Well, if I add up the other three arcs, right? Arc KL, arc KJ, arc LM, and I subtract the arc addition postulate, right? They're all next to each other. If I subtract all that from 360, I'm going to get the value of LM, and then I would average that with KJ, and that's going to give me the value of angle 1. So again, I take these three arcs, KL, KJ, JM, I add them together, I subtract them from 360 to find the measure of LM. That gives me 110 degrees. And so if I average that with KJ, I'm going to come up with something like, well, let's see, 97.5. So I add them together and I divide that by 2, giving me an average between them. So again, sometimes in the exercises, you're going to have to find those arcs and then average them. Sometimes they're going to give you the angle, and you're going to have to figure out how to, from the average, figure out how to get the two figures of the arcs. All right. In fact, in the additional exercises, the last one, number 8, you're given the angle value, and then you've got to find the measures of the arcs. And there's different techniques that you can use for that. Now, what about angle JNM? JNM. So that would be a linear pair with KNJ, or angle 1. And so you would just subtract it from 180, or or you take the two arcs, arc KL and arc JM, you add them together, you average them, right? You add them together and divide them by 2, and you get 82.5. And of course, if you add those up together, 97.5, 82.5, you get 180 degrees. All right. Now, what about if you move this point of intersection between these two secants outside of the circle? Your theorem here, and again, let's repeat this a few times, the measure of an angle formed by two secants that intersect in the exterior of an angle is 1/2 the difference of the measures in the intercepted arcs. So if it's on the interior, it's 1/2 the sum, or it's the average. Now it's going to be 1/2 the difference, okay? And again, just like before with the interior, we have to draw an extra secant to create BE. And what you'll notice is that angle CBE is an inscribed angle, so it has to be half of arc CE, and then you'll notice that angle BED is also an inscribed angle, and so it has to be 1/2 of arc BD. And if you go back to our exterior angle theorem, angle CBE is an exterior angle, so it has to be the value of angle 1 plus the value of angle BED. And so that's why you would want to subtract angle BED to get rid of it, so that you can come up with the value of angle 1. So that's why we're talking about subtracting these two figures, subtracting arc BD from arc CE and then dividing that by 2, because again, angle CBE is an exterior angle and has to equal the value of angle BED and angle BAD or BAE, which is angle 1. Okay? So again, just remember, if it's exterior, you subtract the two arcs and you divide by 2, and make sure you're subtracting the smaller from the larger. Now the same thing applies if we're dealing not just with two secants, but with a secant and a tangent. The measure of an angle formed by a secant and a tangent that intersect in the exterior of a circle is 1/2 the difference of the measures of the intercepted arc. So this is the same principle as the previous theorem, except that now instead of two secants, we're going to have a secant and a tangent. So we would take the value of arc EA, subtract it from arc BA, divide that by 2, and that's going to give us the measure of angle BFA or BFG, however you want to label that. And again, for these, there's a proof here on the bottom of page 377. All right. Now, what about if we're dealing with two tangents? Two tangents. Well, again, the same principle applies, but of course now we're going to be dealing with a major arc, right? Arc CBA, and a minor arc, arc CA, and it's always going to be the case this way when you have two tangents, right? You can't have a point of intersection that's so far out that you're going to have two minor arcs. It's got to be a major arc and a minor arc. Okay. The measure of an angle formed by the intersection of two tangents is 1/2 the difference of the measures of the intercepted arcs. So again, what they're saying is arc CA subtracted from arc ABC, the major arc, you divide that by 2, that's going to give you the value of angle CFA. So here they're saying find the measure of angle YXZ. And again, this is intersecting on the exterior of the circle, right? We're intersecting at point X. So they want us to find YXZ, so that's going to be what? We would have to subtract arc VZ from arc YZ and then divide by 2. Find the measure of arc WY, and they're telling you that that's A degrees. Find the measure of arc WV if the measure of WXZ is 40 degrees. Okay, so if this angle is 40 degrees and you know the value of arc VZ, the value of arc YZ, how are you going to find the measure of arc WY and arc WV? So first of all, we take the difference between arc YZ and arc VZ and we divide that by 2 and we come up with angle YXZ being 28.5 degrees. Okay. Now I know that arc WYZ, so now to find the measure of WXY, I take WXY plus 28 degrees, the value of XYZ, equals the total, right? Our angle addition postulate. So I'm going to subtract 28.5 from 40 to find the value of WXY, right? That's 11.5 degrees. So I know that this 11.5 has to be 1/2 the difference between arc WY and arc WX. So what this is telling us is that the measure of WV has to be A plus 88 arc VZ and 145 arc YZ. All of that together has to equal 360 degrees. So therefore the measure of arc WV has to be 127 minus A. So again, we're continuing with the same problem. Now 11.5 is the total of which A minus 127 minus A 1/2 is 11.5. So now again, they're giving us the angle measure and telling us to find the arc measure. We know that WY has to be A. We know that WV has to be 127 minus A. So therefore, I multiply both sides by 2, right? Multiplication property of equality. I get 23 equals 2A minus 127. So now I'm going to move the 127 to the other side. And I'm going to divide by 2, and therefore A equals 75. So if WY is 75, YZ is 145, VZ is 88, then the measure of WV has to be 52 degrees. Okay. All right. So that's kind of a complicated example, but it just shows you that even if you are given the angle and you know the other arc measures, you can find the missing arc measures for this kind of a problem. And you're going to encounter some of these in your homework. All right, here's your assignment. 2 to 30 even, 2 to 30 even. And again, this is your only assignment this week. And then I want you to do some review, cumulative review, some constructions that go back to chapter 5 when we talked about circumcenters and incenters, and we use that to create circumscribed circles and inscribed circles, right? So you got to remember how to find your circumcenter and your incenter back in 5.1 and 2. And yeah, review the chapter constructions in order to be able to do these chapter constructions and to justify them. All right, folks, again, have a blessed Holy Week. I hope you're able to view some services on Monday, Thursday, Good Friday, and of course on Easter Sunday. So God bless you all. Christ is risen, and hopefully you'll hear from me next week. Oh, remember to get all your late assignments turned into me. The quarter does close on Thursday, okay? Make sure you specifically contact me if you need any kind of an extension.